Hello everyone. Welcome to yet another video on TwinSimulate. In this demo, we will look at the real-time tuning and performance of a discrete PID controller using WinSimRT. Let's select WinSimRT as a target in the diagram. Now, set the sample time to 0.01 seconds and the final time to 60 seconds. In the left-hand side panel, search for the required blocks. Select the arithmetic operators block and add it to the diagram. Double-click the arithmetic operator block and select the subtractor. This block is used to calculate the error between the set point and the feedback signal. Now, search for the tunable PID block and add it to the diagram. This block represents the discrete PID controller. Next, search for the discrete LTI block and add it to the diagram. This block represents the discrete plant model. Next, search for the delay block and add it to the diagram. And right-click the delay block and flip it. The delay block is used to provide the discrete feedback path. Now, search for the RT-HMI panel block and add it to the diagram. Double-click the RT-HMI panel block. Add 3 rows. And change the label names to KP, KI, and KD sequentially. Next, set the initial value of KP to 0. Apply the same value to KI and KD. Add another 1 row and change the label names. Set point. And configure its required range and initial value. Next, add 2 display plots. Configure the first plot to display the set point signal, and the second plot to display the discrete PID controller output in real time. Then click OK. Next, search for the Go to Blocks and search for From Blocks and add 3 copies of each to your model. Next, rename the corresponding block. Pair sequentially to KP, KI, and KD. Similarly for RT-HMI panel block. Use these blocks to connect to KP, KI, and KD signals from the RT-HMI panel and to PID controllers. Connect the set point output from the RT-HMI panel to the positive input of the arithmetic operator, and then connect the arithmetic operator's output to the RT-HMI panel output plot. Connect all discrete control paths as demonstrated in the video. The model configuration is now completed. Click Run to start the real-time simulation. The RT-HMI panel window opens automatically. Initially, the set point is 2 and all PID gains are set to 0. Now, increase the proportional gain, or KP. Observe that the system begins responding toward the set point. However, a steady-state error still exists, since KP alone cannot completely eliminate the error. Now, slightly increase both the KP value and the set point. Observe how the system response changes in real time. Now, increase the integral gain, or KI. Observe that the system responds faster toward the set point. Increase KI, further to improve the controller response. Next, decrease the set point. Then, increase the proportional gain, or KI, and increase the set point again. Observe that the controller quickly tracks the changing reference, however. The response becomes more oscillatory due to the higher integral gain and reduced steady-state error. Now increase the proportional gain, KD. Notice how the output reacts only to changes. When the set point moves, you'll see sharp spikes that quickly decay to zero once it stabilizes. This shows that derivative action responds purely to movement, not to a steady error. This demonstrates the real-time tuning of a discrete PID controller using TwinSimulate WinSimRT. Thank you for watching. Explore TwinSimulate for model-based simulation, code generation, and real-time simulation. Also, explore OpenMath AI, the no-code AI platform for your machine learning projects. Thank you. Stay tuned for more TwinSimulate demonstrations.